In this video, I'm going to solve an integral using integration by parts method. So first, let's write the expression for integration by parts. So if you have u dv, then we can express that as uv minus integral v du. So for this integral where you have an exponential function along with a trigonometric function, I'm going to consider that u function is going to be the trigonometric function. That is, u will be sine 3x. And then dv is going to be e to the power 4x dx. So dv will have that exponential function. So you can see on the right hand side, I need to have u times v. So from dv equals e to the power 4x dx, I should be able to get v. So I'm going to integrate dv, and on the right hand side, that means integrate the function with respect to dx. So then I'm going to get v equals the integration of this exponential function would be e to the power 4x over 4. So that's going to be my v, and then I'm going to substitute u and v to that expression which we defined as the integration by parts expression. So let's substitute for expression 1. On the left hand side, we have e to the power 4x sine 3x dx. And on the right hand side, first we have u, that is sine 3x times e to the power 4x divided by 4. And then we are going to have the integration of v, which is e to the power 4x over 4, and then du. So du would be the differentiation of u. So that would be cosine 3x times 3. That 3 comes from the differentiating the inner function, which is 3x, and then finally the differential dx. Okay, so now and let me define this as I for simplicity. So this is going to be I. So I can write over here I equals sine 3x times e to the power 4x over 4. And then I have, I can pull out the 1/4 from the second term, 1 over 4. Then I have e to the power 4x cosine 3x, and also I can pull out the 3, so I will put that 3 over there. So 3/4 integration e to the power 4x cosine x dx. Now I'm going to apply integration by parts to this integral. Apply integration by parts. Okay, so I can write again this same expression, sine 3x times e to the power 4x over 4 minus 3 over 4, and then I need to integrate this again using integration by parts. So this time I'm going to have cosine, you just follow this method that I explained initially, cosine 3x, and then I would have e to the power 4x over 4 minus sine, and then I have e to the power 4x over 4 times the derivative of the cosine function. So that would be minus sine 3x times the differentiation of the inner function, which is 3x. So the derivative of that would be just a 3 and dx. Okay, so close brackets. This is the same expression from the previous page. So now let's try to simplify this further. So on the left hand side I have I, that is equal to sine 3x times e to the power 4x over 4, and then I'm going to distribute this 3 over 4 inside the curly brackets. So then I'll have 3 over 16 cosine 3x times e to the power 4x, and then I'll have, there's going to be a negative times a negative, that will be positive, but then again there's another negative, so I'm going to have a negative, and then 4 times 4 is 16, and then the 3 will be multiplied by the 3, so then I'll have 9 over 16 as a constant, and then the actual integral, which is sine 3x times e to the power 4x dx. Now, if you look at this expression, e to the power 4x sine 3x dx is our original integral. So that's this same one, okay? So I can call this I. So what I have here is I equals, I can have 1 over 4 sine 3x times e to the power 4x minus 3 over 16 cosine 3x times e to the power 4x, and then I have minus 9 over 16 times I. Now this third term, minus 9 over 16 times I, can be taken to the left hand side of this equation. So then I'm going to have I can be factored out. I'll have 1 plus 9 over 16, and on the right hand side I'll have several common terms. I can pull out e to the power 4x over 16, and then I will have 4 times sine 3x minus 3 times cosine 3x. Okay, and on the left hand side again I can simplify. I get 25 over 16 I equals e to the power 4x over 16 times 4 times sine 3x minus 3 times cosine 3x, and then the 16 on the left hand side and the 16 on the right hand side cancels out. So my final answer I can write here, I, that is that original integral, is equal to e to the power 4x over 25 times 4 times sine 3x minus 3 times cosine 3x. Now remember, this I stands for an indefinite integral. So to be complete, we have to put a plus c, indicating that it's an arbitrary constant. So the final answer for this integral is this expression. So this one is the final answer. So that's how you do this problem.